Good morning, students. Today we are going to study integral rate equation. So we have studied two types of rate. One is instantaneous rate, another one is average rate. This instantaneous rate can be determined very conveniently by the integral rate equation. So we have to integrate the rate equation. So how to integrate it? Let us see. First we will take for zero order reaction. For zero order reaction, consider the reaction R will gives of the product. That is, reactant will gives of the product. So here the rate of the reaction is proportional to the concentration of the reactant. What is the reactant here? R. Here it is a zero order, so I have to put the power 0. Now to remove the proportional, I have to put a constant. The constant is K. So this is the rate law. This is known as rate law. Now the rate, already we know the rate can be written as minus dr by dt is equal to K into R power 0. Anything power 0 will be 1. So I am right, instead of this I am not into 1. Into 1 is the K. So minus d, why you are putting minus sign? Because concentration of the reactant will decreases during the reaction. Now this is the differential form. This is the differential form. Now we have to integrate. So integrating both sides. Before you are going to integrate, I am bringing the dt term to the other side. So I will get the integration of dr and the integration of k dt. So here k is a constant, so I am taking the constant outside. So here dr, so we know that the integration of dx is x. So x, so integration of constant, see t time equal to minus kt plus I is an integrating constant. So I is an integrating constant. So what is the value of I? How to calculate the value of I? If time equal to 0, see at 0 time, see what is the concentration of the initial concentration is R naught. R naught is the initial concentration of the reactant. So whenever the time goes on, the concentration of the reactant is slowly decreases. So here integration of dr is equal to k dt. So here I, instead of I, if I t equal to 0, if time equal to 0, what is the value of R? R equal to R naught. So here I am substituting. So if I t equal to 0, then I have to put R naught. So k into 0, anything power 0 equal to 0. So this term will become 0. Then you will get R equal to R naught. R equal to R naught. If time equal to t, then R equal to R naught. Substituting these two in equation number 1. In equation number 1, if I substitute, then the equation becomes R equal to minus kt plus R naught. So now minus term you bring it to the other side. When minus term bring to the other side, it will become plus term. So kt equal to R naught. I am bringing this R to other side. So R naught minus R. So what is k? K equal to R naught minus R by t. So this is the equation or expression for rate constant. So this derivation is important. Derive the expression for rate constant for zero order reaction. The question they will ask, derive the expression for rate constant for zero order reaction. This is the derivation. So what is the answer? K equal to R naught minus R by t. So two graph we can explain for zero order. One is, so this is a decreasing curve. So decreasing curve means if time increases, the concentration of the reactant is decreases, or we can also say negative curve or negative line. So here this equation is in the form of the straight line. What is the equation of the straight line? Y equal to mx plus c. So here the m stands for the slope. So in the place of m, what is there here? In the place of m, minus k is there. So slope is minus k, or k equal to negative slope. And another graph also we can draw. For if you take a rate in the y-axis and concentrated in the x-axis, we will get a graph like this. So these are the two graphs for zero order reaction. Example for zero order reaction is ammonia. Decomposition of ammonia is into nitrogen and hydrogen, and the decomposition of iodine, Hi into hydrogen and iodine. These two reaction takes place in the presence of catalyst. So they are the examples for zero order reaction. So this derivation is important. This is the derivation for rate constant for a zero order reaction. Okay, thank you, sir.